Hello and welcome to a discussion on the preparation of air. Yeah, like what we do with air. Like we have to condition the air for pneumatic systems. Actually, let's talk about why we may have to do that. Like, hey, what's the problem with air? Well, when we compress air, we take it like it's this big and then we make it that small. Actually, it's quite remarkable how small we make the air. Like a compressor essentially takes like this much, like a lot, like this much air and makes it into like this small or even smaller. So if I had like a lot of contaminants in the air, maybe some dust. What else is in the air? Okay, water, yeah, vapor, water vapor, big deal. What about like smoke and stuff? What if somebody's smoking? Like you never know what they're smoking either. So what about like, I don't know, other kinds of fumes? Is there anything else in the air? Wait, I have to think. This is broken. This is falling down. Stop that. Yeah, there's other stuff in the air. Like bacteria. Really? Is there bacteria in the air? Yeah, there's bacteria in the air. There's there's lots of things in the dust. And then what about other kinds of particulates that may be in the air? Hey, what if like maybe we were in some other kind of like manufacturing facility? What if we were like painting stuff? Or maybe using like glues? Or yeah, like fumes and stuff from glues and other things and other kinds of particulates. Oh, what about like sawdust and all different kinds of dust and like metal dust and grinding dust and yeah, all of these things are in like all different kinds of facilities where you may have to use a compressor. Huh. So compressors, they suck a lot of air in from the atmosphere, like a lot. Like they do that all day long. So actually, if you were to imagine, like, let's just say, here's my lab. I got a little tiny compressor there. If I ran that compressor, like, I don't know, for like 5 hours, a long time. But if I did, it would probably actually circulate all of the air in this room. So air would have to come in to replace it and whatever. But I mean, this air's got a lot of stuff in it. So that's happening all the time. So you can imagine if a compressor is going to run for like 1,000 hours, it's sucked in a lot of air. And that air has got stuff in it. So we have to filter that stuff out. It's actually really very important that that stuff gets filtered out. Because if we don't, if we leave it in there, what's going on is that all of that stuff, it can damage the components. It can do a lot of damage to the components. It can damage the compressor itself. And then we're going to compress it. And those particulates are going to be like compressed, going to be denser. And then we're going to shove those into like pneumatic actuators and like all different kinds of components and like pressure regulators and lots of other stuff. No, let's not do that. Hey, let's think of ways to not let that happen. What I'm going to do is I'm going to talk about this stuff. So we're going to talk about how we can remove particles from the air, different kinds of ways that we can do that. And then we're going to talk about removing moisture from the air because that's like pretty much the secondary or sometimes the primary thing that we actually have to remove. But pretty much we're going to break it down to two things. We're going to remove like stuff, like physical like molecules that are in the air that are not water and particulates and stuff. And then the reason I said molecules is because sometimes it's vapor, which is pretty cool. But yeah, generally like dust and just particulates and then water. And water is like huge, creates huge problems in pneumatic systems. Then we're actually going to talk about heating and cooling of air because we're talking about the conditioning of air. No, we're not talking about air conditioning. But ultimately, air conditioning is a pneumatic thing. That's pretty cool. It's a thermopneumatic thing as well. So cool. Thermopneumatics? Don't even get me started. Okay, good. And then we'll take a look at some symbols because symbols are probably really important. Yeah. Okay. So what's going on here is that talking about contaminants, what we're going to do is we're going to like talk about the different kinds of contaminants, and then we're going to look at like how big they are, what the size of the contaminants are. Okay, so atmospheric contaminants are water vapor, dust. Actually, water vapor is like on the top. It could be below, depending on where you are. Like if you're in a really humid environment, water vapor is like a huge problem. And then, dust and then fumes and bacteria. Yeah, bacteria. But wait a second. What's wrong with bacteria? I mean, why wouldn't we want bacteria in our pneumatic system? Well, guess what? We're bringing water into our pneumatic system. We're compressing bacteria in because it's in the air, especially when you like sneeze near your bacteria, near your compressor. Don't sneeze near the compressor. Like, Oh yeah, I'm just kidding about that. Yeah. No, I'm not. Okay, let's move on. So, yeah, generally we don't want bacteria in the compressor, and the problem is because it ends up in the tank. Because the compressor compresses air and then shoves it in the tank. So there's bacteria in the tank. And when you compress air, it gets really warm and it's really moist. So now we have warm air, really high oxygenated air, like the air density is so high with oxygen, so it's like feeding it, and it's warm, and we have water vapor. Is that a good environment for bacteria? That's a problem. So we want to make sure that we do that. And then the other thing is that other contaminants in the compressor system can be actually stuff that actually happens because of the physical compressor, because it's like metal, and that creates contaminants as well. And the other thing is that we also put lubricant. Yeah, sometimes, rarely, pretty much not anymore in like the modern age, do we put lubricants in. Okay, bye. Hello, I would like to introduce you to the Thing. And the Thing too. You are the Thing. So even little tiny little things can damage pneumatic systems, like super small. And sometimes, depending on what we know is in the environment, we actually may get a different filter to filter things out. Certainly fume, if we know that there's a lot of fumes, we can get specific filters for that, and they have really tiny little mesh that will stop fume from coming in. So essentially, we're going to like measure things in microns. I just want to give you an idea of like what a micron is and maybe how big the particulates and contaminants are that come into a pneumatic system are in microns. Because when you're going to be ordering filters and looking at filters, you will see that they are rated in microns. So essentially, we've got this little chart here that's going on, and it's actually interesting. So this gives you like a perspective. 70 microns is a human hair. I don't know, some hair is a little thicker and some hair is a little thinner, so it's pretty average, whatever, 60 to 80 or something, right? And then once you go below 40 microns, you can't see it anymore. It's beyond the visual range. And then, you know, a white blood cell is smaller than that, and we go down and down and down. So we get into like the 2 microns, and we can see that some bacteria are actually that small. So sometimes we actually need really intense filtering. But in this case, let's just take a look at maybe some more sizes. Essentially, a grain of salt is about 100 microns, and then 70 microns is a hair, and then if we go a little bit lower. So that's what's going on. And I don't know if you know what a thou of an inch is or a tenth thou, and you may be able to say, yeah, that's about a tenth thou. Well, that's about as small as you can see a tenth thou. Below that, you can't. Whatever, it just gets small. So maybe you don't know what I'm talking about, what a thou is. That's okay, we can move on. Pneumatics, it doesn't matter. Just trying to give you a perspective of the sizes of some of these things, so that when you're kind of ordering these types of filters, or when you're looking at specs, you can have an understanding of how small something is when it's being filtered. So this is the basic symbol for, oh, there you go. That's a basic symbol for a filter. So there are different kinds, but that we start with that thing. That thing filters particulates out. And it's not specifically designed to filter water, although it does filter water. So sometimes when we're filtering a lot in a really humid environment, we have another symbol that we put in there indicating this also filters water. But whenever we're filtering just particulates or whatever, contaminants of some type that have a physical size to them, other than water, that is the symbol that we use. So it's a basic symbol. So essentially, there are kind of 2 sides that we're going to be talking about. One is filtering air into the compressor, and then filtering the air after it leaves the compressor, and we have names for that. So this is, sorry, there you go. So filtering air into the compressor is the breather. So just remember that. Breathing. When you breathe, you have air coming in. I don't know, just remember it. However, you have to remember it. So when the compressor is breathing in, it uses a breather filter. Now, pardon me, often the breather filters, they're made with just, not really, really high filter material. We actually can filter the stuff after it goes through the compressor, but essentially the breather is taking out really big particulates, like dust, like big particles of dust, like sawdust and stuff like that. And these are often made with material like cotton or felt, and they're held in a mesh. Sometimes they're just actually a fine mesh, depending on what you're actually filtering. If you're in a really clean environment, you can just have a fine mesh. But generally, you'll find some kind of felt or cotton in there, and you'll have to replace it often. You really have to think about it. So if you're in a really dirty environment, you want to go over and replace that. Just check it out for the first little while. Like if you're just like at first, you're like, first it's your first compressor or your first time you're managing a compressor, go over and check that first. And then say, okay, well, you know what? I'm just going to watch this and go check it every few days to see if it gets dirtier or dirtier, depending on the use. So yeah, just keep an eye on that. It's important that you kind of keep an eye on that and that you change that regularly. And by the way, it's really easy to change. It's just a matter of like just shoving some new felt in there. You can get a little pad and put it in there. So even if you've changed the breather filter on a lawnmower or on a little gas engine or something like that, that you're used to seeing that kind of mesh kind of thing in there. So it's pretty basic essentially. So there you go. So after the compressor, what we call as opposed to it's calling a breather, it's called a strainer. Okay, so we've got two kinds of filters. One is pre-compressor, one's post-compressor, and the one going into the compressor is the breather. The one that's filtering air coming out of the compressor is a strainer. Okay, good. So the strainer is filtering out. We can get really, really fine mesh strainers or really small micron strainers. So this is what's going on. So this essentially it's the air coming out. So now we've got a couple of different kinds of these strainers. Actually, there are lots of them, but there's some basic kinds. And let's just take a look at this. So it kind of looks like this is what's going on. So the air comes in here and then it goes through here and it's got to go, it's actually forced to go through all of this stuff here. And this is a fine mesh material. And there are lots of different kinds of materials that we can get these meshes out of. But essentially the air is forced through here and it comes out. Now, and then essentially it's going to go back in here. So it forces it in here and then it comes out here. So it comes in from here, it comes in from all angles. This whole area here has got the compressed air in it. It's forced to go through here and then it comes out. Now, what happens is when the air is going through there, there's a dynamic in there. It's moving, right? What happens is the water, the vapor that's in there will get stuck on all of the surfaces. Water likes to stick to stuff. So it'll get stuck on all those surfaces, and this baffle here actually manages the water. So it collects the water and it drops down the baffle and it falls into the bottom here. And actually we have to drain this. So often these get full of water. And again, that depends on the environment that you're looking in. So all of this filtration, it's completely, entirely, so very dependent on the environment you're in, what the atmosphere is like. Okay, good. So that's what's going on there. Let's take a look at some of these filter elements that get put in here. So what's happening here is that you can have a depth filter or an edge filter. And what's going on is this has got little pieces of carbon in it. Carbon is fantastic at removing particulates from the air. It loves particulates. It just sucks them up. It's like full of holes and it sucks them up. So we can get a depth filter that has these little tiny little particles of charcoal in there, carbon charcoal, and the air is forced through these little tiny bubbles that are going through here, and this collects all of the material. We can also get an edge filter, and they're different kinds depending on which one you buy. I just need you to understand the fact that there's a filter in there. We're not going to get in more depth into what different kinds of filters do. So right now, not right now, what we're going to do is, but essentially, not the materials, you can just order them depending on the size of particulates you want to filter. So that's going on. Now let's take a look at this. What's happening here is that you can also get just a brass element in here, and this lasts a very long time, but you have to clean it as well. So either you can then replace these filters, and they're just like kind of drums that just kind of rotate it. So you just have to service these things. So you take that round thing off that you see there, you unscrew it, and you pull it, you unscrew the filter, and you put a new filter in and you screw it in. So what's going on is if you get a brass filter, you can actually reuse the brass filter and you can just clean it. You can put it in, actually you can put it in some kind of particular, it's like you can put it in some something that's acidic and or basic, and you can kill some of the materials in there. But essentially the best way to clean that out is with some soap and water, and then get your air, like pressurized air, and just blow it backwards. Try and blow air into it and just vent it all out. There you go. So that's what's going on. You can see this little screw here. So this is also exchangeable and or removable. Cool, eh? So let's go on to some symbology. Now, this lecture is not actually going to be too complicated. There's no theory that I need you to learn. I need you to understand the practical application of the conditioning of air. That's it, just some terminology. And I want you guys to start putting these symbols into your pneumatic drawings. So from now on, I'm going to give you conditions, the environmental conditions, and then you've got to choose the right pneumatic filter to go in there. Okay, good, here we go. So filter symbols. Like I said earlier, what's going on is that we've got air going through here that the water is getting sucked out of. When the air is going through the filter, it's actually losing air. A lot of that losing water, losing that vapor goes out, unless it's really dry air. But if we know that it's air that really is very humid all the time, then what we want to do is we want to put a drain in here. If it's dry air, you don't need a drain. And then every once in a while, like, I don't know, like whenever you change the filter and you undo that, you may see a little bit of water in it. You just dump it out. But sometimes it accumulates big time. So you want to have, well, pardon me, you want to have the ability for a drain. So you've got this thing with a drain, and there's a little screw on the bottom, and you just undo it and the water just drips out. And actually the pressurized air forces out as well. So you can get the water out of there. Now, I've got a microfilter. So microfilters, you can just go buy a microfilter and it will say the spec of the microfilter on it when you buy it. And that will be in microns. So depending on what you need to filter out. Now, microfilters are used for fumes. So if you want to get fumes out of here. And also, there are other types of ways. There are oil bath filters where the actual air has to go through a bath of oil to get out. And that actually collects so many particulates, but it also can collect fumes. Okay, good. So what we're doing here is that's a microfilter, and it's for really fine material. Now, sometimes, if it's really a very humid environment, that drain that you go over to and manually do it, it may be that it's so often you have to do that like every day, well, or at least once a week or something. That's pretty often. Then, depending on the facility you're in. And then what you can do is you can auto drain. And auto drains are pretty cool. Just let me give you a little example about an auto drain. So moisture removal, auto drain. What's going on here is it's kind of like a bowl in a carburetor. Whatever that is. Anyway, let's go on. Some of you may know what a carburetor is. Let's just take a look here. So I've got a little bowl here, and they've got some liquid. When the liquid gets to a certain level, it pushes the bowl up, and then from there, it actually opens up the vent, and the water comes out. So in this situation, you actually may want to put a receiver in there to collect the water, or actually have a drain under it. So pretty cool. So moisture removal is like a whole thing. Yeah, like I said earlier, like it's like a whole thing. It's a really big deal. So moisture can cause a lot of damage to pneumatic cylinders, to the actuators themselves, to the valves themselves. They can create rust. The actual water itself can get stuck in all different kinds of components that are inside there, and it may damage all of the components, create rust, and essentially we got to get rid of it for many other reasons, because sometimes whatever the thing is that you're driving, you could be putting it into a very dry environment. For instance, paint. Like, I'm not sure if you guys know this, but the paint sprays, like in automotive shops and stuff like this, or wherever actually in manufacturing, whenever you are spraying in an automated manner, you're spraying paint. Well, they don't get spray cans. You use pressurized air to actually spray the paint. Well, it's actually really, really, really serious. You don't want any water in that paint, like at all. No, like at all. So I have a good friend of mine. He's got an auto body shop, and he's got these huge filters. Do I actually have? Yeah, I do. I actually have. I'll show you how extreme some people go to remove moisture from the air. So he's got these huge filters. I don't know. They're like this long, and they're like this round, and they're yellow. And they're beside his compressor, and there are actually two of them. And he uses those, and he has to drain them all the time because he's actually pulling a lot of water out. And he's just, in Northern Ontario. Actually, Northern Ontario in the summer can get pretty humid. But my point here is that he's really interested in taking water out. So in some situations, you really want to change. You want to kick the water out. Now, what makes mountains come down? Water. I said that funny. Water. Yeah, water makes mountain comes down. So what happens is the water gets into the cracks, and then not all mountains freeze, but because they're mountains, it's pretty cold up there. The water freezes, and water freezes, it expands, and then it breaks the rock. And then in the spring, when the water melts, it actually removes the rock, and that's how mountains fall down. Yeah, water is actually quite remarkable. And it can do the same in pneumatic systems. So think about it. If you have a pneumatic system and there's water in there for whatever reason, and anything, your pneumatic tool, your pneumatic actuator, the valves, the lines, the whatever, the compressor itself, the tank, whatever, the regulators, everything. If there's any water left in there, and for whatever reason, if that system has to freeze because you're letting it idle for a while and it's in a cold environment, it's going to break your system. So water, it's bad. Yeah, just don't let it in your system. Get rid of it. Okay, good. So here we go. So, yeah, it comes from the air. This is where it comes from. And we have two ways to get the water out. One is we have moisture separators. Moisture separators are physical things. They actually have physical stuff in them that actually attracts the water. Because water has this ability to just like suck on things. Like the water tension itself, the surface tension actually grabs onto stuff, and then you can hold on to the water. So the other thing is that we have moisture separators. Yeah, they're actually things that actually are powered. And that's pretty serious when we actually have really serious situations where we actually have to take water out. So let's just take a look at the kind of mechanical operation of actually taking water out of the system. We'll look at some symbols, and then we'll take a look at some other options for removing water. So essentially, what's going on here is we have a desiccant. A desiccant is something that can absorb water. Also, carbon is a really good desiccant as well. It just sucks up the water. So what's going on is that we have desiccant filters, and we have different kinds of desiccants. Silica gel is pretty much the most common. So, and they're just these little tiny little balls or beads that the air has to go through, and the water just gets sucked onto those beads, and eventually the water will collect, and then it will drop out because it's water. It's hard to get the water. It's easier. Get this, it's pretty cool. Physics. It's easier to get vapor turning into water than it is getting water to turn into vapor. Okay, cool. So all we have to do is like grab onto it and turn it into water, and it just stays that way. Pretty cool. So what's going on here is that it's important to note that, it's important to note that when we are putting in a moisture separator specifically to our compressor, to our pneumatic system, what we do is we put that moisture separator right after the compressor. Because essentially what's going on is if there's a lot of moisture coming out of your compressor, because it went into your compressor, if you put it through a filter, that's cool, but the filter will actually remove some of that water. But what you want to do is that's stressing your filter to some degree, or sorry, your strainer. Yeah, because the strainer is after the compressor. We can also call it a filter because there are two kinds of filters. One's the breather and one's the strainer. So the strainer itself gets pretty stressed dealing with all that water. There's a lot of moisture in there. So what we do is we put a moisture separator in, and we do that. And essentially that is the symbol for a moisture separator. That's the basic symbol for a moisture separator. Get a little bit more complicated than that, but that's it. Actually, I'll just go back a couple slides. And this is a moisture separator with auto drain, and it's got a filter in it as well. Cool. So that's a filter with an auto drain, or we can actually just get a moisture separator that actually has an auto drain as well. Good. That's just a basic moisture separator, and that's it. That removes the moisture. Okay, cool. Now, this is where we get into the point where we're going to actually, because I had two of these things here, and we had something called an aftercooler. Now, an aftercooler is an actual powered device, and what it does is it works like this. It's pretty cool. What we have is that we've got these pipes that are going through a chamber, and that air is going, the pressurized air is going through that chamber. Why is it called an aftercooler? Because we remove the moisture after the compressor. I mean, you can move it. You can remove air before, you can remove moisture before the compressor, but you have to do 10 times more work to do it. Or whatever the pressure, whatever the pressure ratio is. So essentially what's going on is that the atmosphere is 14.7 psi A. And let's say we compressed air to 100 psi A. We're compressing it 10 times. Okay, so what I'm saying is it's 10 times more difficult to remove the water from the air before it goes into the compressor, because as you put air in the compressor, you compress it, and that water actually doesn't like to be that. It has to do with the dew point. We're not going to talk about dew points. Okay, what I'm just saying is that the water can't, the air, the pressurized air can't hold on to all that water. It actually just drops it out really easily. So what we do is after the compressor, we put it through a really cold environment. And we know what happens when water and cold get together. All of you have had a glass of water sitting outside in the summer and it's got all the drops on it. Essentially, that's what's going on. So you make this water go through this chamber with these cool pipes that have either cold water through them or refrigerant. But we don't want it too cold because then we're going to freeze that water. And the air itself being really cold, really like frozen air, like air below zero, we don't like to put that in pneumatic systems. It stresses it. So you don't want to like freeze the air, but you want to remove a lot of the water. So you just get that really cold. So it's cooling water, but some of these have actual heat exchangers that are run for industrial systems that are run with AC systems. Okay, here we go. So, or compressors. So here we go. So these are the symbols. I mean, it's really complicated. Yeah, that's it. So there you go. So those are the two options for moisture separator. One, they both have drains. I mean, essentially a moisture separator has to have a drain. And that's it. So we don't actually, there's no symbol in here indicating how it's separating. That's it. So that's the moisture separator, and this is a moisture separator with an auto drain. There you go. So here we go. So let's talk about heating. Now, in some cases, we want to heat air. Like I said, pneumatic systems don't like really cold air. So sometimes we're dealing with really cold air, and we want to heat it up. So this is the symbol. This is the symbol that's going on here when we're dealing with a heater. So when we heat air, that's the symbol. And these arrows are going here. Now, an aftercooler is the opposite symbol. And we'll see this because I think, yes, I do. I have a slide here. Good. Here we go. So an aftercooler, an air dryer is like this, or more specifically, an aftercooler is a type of air dryer. Okay, good. So the air dryer is air cooler, pardon me. The air cooler here is doing this, and it's drying the air. So we've got the symbols, the arrows are pointing out. Now, I don't know how you want to remember why. If you're cooling it, the arrows go out, and if you're heating it, the arrows go in. I think about it like this. When we heat something, we're actually compressing the heat. We're kind of like, okay, go, just you're compressing heat. Sorry, when we raise the temperature of something, we're compressing the heat. That's what actually happens when things get hot. We're actually putting heat into it and compressing it in there. Then its temperature goes up. It's so cool because we're going to study the difference between temperature and heat after the midterm. Okay, let's continue. So yeah, we've got some symbols here, and that's what's going on. And then these are all the symbols that you guys learned. That is a multi-stage micro. So essentially, what's happening is that I've never seen a symbol for a microfilter that isn't a multi-stage. Because if you think about it, yeah, if you're trying to filter like a lot, you might as well have like a dual stage in there. So yeah, the multi-stage, the microfilters are really, really tiny little lines. And there you go. These are all the basic symbols. Heat exchangers, those are pretty cool. We'll talk about heat exchangers when we get into actually building compressors. And then we'll see a symbol like that. And that's it. Not yet, because I want to show you one more cool thing. Now, somebody went to some really serious business to get some water out. And let's take a look at this. What's going on is, remember how I told you we put our air filters after the water separator? Let's take a look at this. What's going on here is that somebody made some kind of system here that is actually removing a lot of water from the system. So it's kind of like MacGyvered or makeshift, but that's okay. It's working. So the air is actually coming in from over here. The air is actually coming in from over here. It goes down here, and then what's happening is that there's actually a drain in here. Let's take a look at this. There's actually a drain in here, and a drain here, and a drain here, and there's actually a drain at the bottom of the moisture separator as well. And what's happening is that the air comes in here, and then it's got a lot of surface that it touches on this pipe, and then it comes here, and some of it kind of thinks, do you know what? I'm going to fall out. This little kind of vapor says, no, I've had enough. I can't it can't be vapor anymore. I kind of feel like I'm going to turn into a water droplet. And as it does that, it comes up here, and then it can't make it. As it's way up this channel, it says I can't make it all the way, and it drops down the bottom. And then the rest of the air comes here, and then the same process happens here. Some of the water is removed. It can't quite make it up this pipe, and then it comes down here. The same thing can't quite make it up this pipe, and then it ends up collecting here. So at some point, somebody's going to undo these valves to get all this air out. Then this air comes here, it comes all the way down here, and it goes into the moisture separator, does the same thing, comes out of the moisture separator, and then it goes into some kind of filter and a pressure regulator. So this pressure regulator is after the water separation. And then that's your line. That red line goes to whatever the system is that Buddy's using this air for. There you go. So thanks for watching. I hope you enjoyed that. Again, there's no lecture material. Essentially, you just have to know this stuff. This stuff is not actually on the midterm either. It's okay. I just need you to understand the terminology and the knowledge and have access to this information so that when you do your designing in the future, you can add this stuff in. Okay, bye.